5 interfacing microcontroller. So we are going to discuss about the topic serial port programming. In last lecture class we have discussed about what is 8051 timers. So now we are based on wheel traveling what is serial port programming. So in first in serial port programming we have to know what is parallel communication, what is serial communication. So parallel communication and the serial communication we already seen in 8086 microprocessor as 8255 for parallel communication, serial communication 8251. So the difference between parallel communication and serial communication is given here. So for serial communication we can transmit 1 bit data at one time, so sender to receiver. For parallel communication we have to transmit more number of data at a large time. So example, printer for parallel communication. Next, serial communication, telephone line. So basics of serial communication is given as synchronous and asynchronous method. So synchronous means block of data at a time. Asynchronous means transfer a single byte at a time. There are special ICs for manufacture for serial communication, UART and USART. Universal asynchronous receiver transmitter, universal synchronous asynchronous transmitter. So UART is nothing but we are transmitting a data from transmitter and we are receiving data at receiver. So 8086 we have seen a program based on 8251 in mnemonics. Next we have to discuss about what is duplex, what is simplex. So duplex is nothing but we are transmitting and receiving the data in both directions. Simplex is nothing but we are transmitting data in only one directions. So in duplex there are two types, full duplex and half duplex. So full duplex is transmitted both the way at the same time, either from transmitter to receiver or other from receiver to transmitter. Half duplex is transmitted one way at a time, either it can be transmitted from transmitter to receiver or it can be transmitted from receiver to transmitter. So at a time we can transmit only one path of time. So next we have to see what is asynchronous. So in asynchronous there are three logics we have to follow. First one is stop bit and another one is stop bit. In between we have to send the character oriented transmutations. So in upcoming examples what you have given is we have to start the bit with low, that is 0. In between we have given 41 bit 010 010. The ending bit we are setting as stop bit. We have to mark how the data is transferred. So next one is data transfer rate. Data transfer rate can be measured by bits per second. So for bits per second we are going for a parameter called baud rate. So baud rate is nothing but number of signals channels changes per second. So basic baud rate we are used in 9600. So in the most important part we are going to see now 8051 serial port. Asynchronous and synchronous we have already seen. So SCON register used to control data transfer. Data occurs by transmitter and receiver pins. Clock also occurs by receiver pin. There are four modes of operations: mode 0, mode 1, mode 2 and mode 3. So first mode is used for synchronous serial communication. Just we have to transfer some data by serial communication code by transferring. Next one is mode 1, mode 2 and mode 3. So mode 1 for 8 bit UART with timer data rate. Mode 2 9 bit UART with set data rate. Mode 3 for 9 bit UART timer data rate. So mode 2 and mode 3 are some are similar. The registers related to, we have to know some registers related to serial communication. Serial buffer register, serial control, program control register. So next we have to see serial buffer register. Serial buffer register is an 8-bit register used for serial communication. So a byte of, if we have to transmit a byte of data, we have to use transmitter line for serial buffering register. So it may holds it is received by 8051 receiver line. So serial buffer is nothing but we have to transmit the data from serial buffer register. So serial buffer register is nothing but we have to how the data is transmitted from character oriented to single oriented. So move serial buffer to D, then we have to the data can be transmitted to A. Another thing, the data is finally received in serial buffer. So we have to see SCON register. So in last class we have seen a TCON register and T mode register. So in the ESCON register has 8 bits. So RI for receiver, transmitter, RB for 9th bit in mode 2 and mode 3, TV transmitted bit in mode 2 and mode 3. We have to RIN is nothing but we have to enable the pin. Then SM0, SM2 and SM2. Enable multiprocessor micro communication mode. So first two bits are used to identify to set the mode 0, 1, 2 and 3. So we have to see the major part 8051 serial port mode 0. Serial data enters and exits through receiver and transmitter acts as a clock and 8 bits are transmitted and received. So baud rate is fixed, generally 9600 is a baud rate fixed rate serial communication port. Same thing followed in mode 1 is nothing but same thing process how we are data serial data. Next one serial data can be exits to, if we are getting the data to receiver, then we are transfer the receiver to receiver. And receive the stop bit can be received in RB8. RB8 is nothing as special pin used in mode 1. 10 bits are transmitted and received. First thing is stop bit, data bits we already seen asynchronous data bit, then stop bit. So baud rate has been identified, also been time row. Next one mode 2. Mode 2 the same process except the third step we have to extra and comparing one mode 1. Also in fourth step whatever followed there is 10 bit. Here for mode 2 we are using 11 bit. So in mode 3 the same data we are going for same thing. We have to identify the what is mode 2 and mode 3. The similar thing we have to follow in mode 2 and mode 3. But the basic difference is in baud rate only we are programmable in mode 2. In mode 3 baud rate is driven by timer on overflow. There are some programs related to 8051 serial port. First you are getting the baud rate 9600, 4800, 2400 and 1200. So for transmitter we have to see some program, for receiver we have to see from program. Same logic for transmitter and receiver program. First one you have to assign T mode registers 20H. So timer 1 mode 2. Then TH value you have to set as baud rate. Another ESCON register, control register can be 50H. So control register can be allotted by the ESCON register. Then we have to set the transmitter value. Then we have to move the character. Then we have to jump non-bound 0. And transmitter value can be allotted from loop. Then we have to clear the transmitter. So we have to repeat for if there is upcoming register, upcoming character we have to repeat. For receiver the same step what we are followed. First 3 steps, 4 steps are similar except we have to in jump loop looping concept we are declared as TI, here we declare as RI. So move A serial buffer, clear TI. So we have to transmit the data A except comparing the loop we have to assign T mode TH baud rate fixing ESCON register set B where tier 1 move SB character A. The character A can be at last denoted as move A comma serial buffer. Also you have to clear, we have to end the program. So end the program means end the loop because we cannot just we are giving the one character only for transmitter. So then we have to receive the program. For receiver purpose the same program to be followed except the looping concept and the clearing RI must be changed. If you have to declare the message yes, we have to declare one by one. Thus we are transmitter program. Move T mod 20H, move TH baud rate setting, ESCON register, set B TRI. Again we are transmitting one by one character. What you already seen A message. Move A. We have to first denote Y value. Next we have to denote E value. Next we have to denote S value. Again we have to A call. Automatic we have to call the transmitter register. So thanks for watching the video. If you have any queries related video and lectures, kindly intimate me. Thanks.